This is the resistor. The definition of the resistor in the electrical network has two parts. First, we say that the resistor is defined as a passive electrical component. It is defined this way because it has no need of a power source and it uses the power that is given by the network itself. Second, we say it is used to limit the flow of the electrical current on a circuit. This component will create a resistance in the flow of electrons and limit the current in the network. How will it perform this, being a passive component? Well, due to the resistor characteristics, power will be lost by Joule effect. When an electric tension is applied in a circuit, current will flow according to the resistance of the circuit. As we can see by Ohm's law, voltage is proportional to the product of the resistance and the current. This means that the current will be proportional to the division of voltage by the resistance. So for a fixed voltage, we can see that the current will vary accordingly to the resistance on the circuit. We can also see that if the resistance is zero, an impossible situation will happen, the equivalent of a black hole in mathematics. This impossible theoretical situation is translated to what is called a short circuit, something to always avoid at all costs. A voltage source cannot support infinite current, and so sparks will happen. There are many types of resistors. Commonly, we can say that resistors are divided in two groups: linear resistors, non-linear resistors. A linear resistor is one whose resistance doesn't vary with the flow of current through it. The current through it will always be proportional to the voltage applied across it. Some examples I currently have in my lab are fixed resistors, such as carbon film, metal film, and SMD, variable resistors, such as potentiometer. Non-linear resistors are those types of resistors where the resistor characteristics change according to some nonlinear algebraic equation. For the purpose of this video, we will focus on the basic fixed linear resistor. A carbon film resistor is a component that has a ceramic core. Around this ceramic core, a carbon film with helical cut is put. It is the characteristics of this cut that will give its resistance value. The extremities are conductive leads, and on the outside, an insulating coating is put. I have cut a carbon film resistor. As you can see, inside it is the ceramic core. The carbon film and coating are too thin to see, but they are there. Have some faith. Values of fixed resistors are calculated according to the resistance table. Applying this to this particular component, we see it has 4 color bands. First and second bands give the significant digits, in this case 2 and 2. Third band will give the multiplication factor, in this case it is a value of 100. The fourth band will give the tolerance value, in this case around 5% of potential variability. Hence, we have 22 times 100, which will give a value of 2200 ohm, or 2.2 K. As we can see, the multimeter will indicate the resistance on the component, confirming the previous calculations. Please bear in mind that due to the potential variability given by the tolerance, the value is expected to vary from the exact calculation a maximum of 5%. In this case, as you can see by the calculations above, we can expect to measure a value between around 2.1K and 2.3K. We will now connect the resistor to a power source. If we set the power source to 12 volt and already knowing the value of the resistor, we can calculate the current on the circuit. From our calculations, by Ohm's law, we can see that the expected current is 5.46 mA. If we confirm with the multimeter, we can see that this is accurate. All hail mathematics! So, this is the basics of the resistor. Now you can never say that resistance is futile.